this was from a methods class, and I have nobody put their name on it, so I have no idea who did this. So it's older.
Ended up in your file.
But it's, yes, because I save all these things. I have an incredible amount of files. But anyway, when Mary brought it up the other day, do you think, well, you can see if it's yours, could be Joe's. Mary asked about the algebra tiles. And so I went through and thought, well, we could talk about them, and obviously you've used them, so, feel free to add whatever difficulty you've had with them. I know a number of teachers, have you used them? Have you been using them, Jay?
I've tried, and for some reason, they don't like the tiles, but they'll use diagrams, they'll do that.
Absolutely,
I don't understand.
Yes.
But they'll do that.
It's because it seems somehow babyish or something if they have to use these physical materials, but they're willing to look at the diagrams. Yeah.
So,
What game we're playing with.
Starting about middle school, that starts.
See if this works.
I think they get better when they get older, they're more willing to use it, at freshman level.
There you go, I'm not helping you, Mary. Can I
Oh,
help
no,
you?
that's okay.
Okay.
Can I open
So-
these, or are there other
no,
ones?
no.
You can open them, yeah.
Yeah.
Sure.
Yeah, oh, yeah.
Okay.
So what are they? Obviously, you see them in front of you. They're a set of shapes: big squares, small squares, rectangles. And big squares, we say their dimensions x by x. So we have each large square is x squared. The rectangles have dimensions 1 by x, and then the little squares have dimensions 1 by 1. And sometimes they talk about y rather than a 1, rather than having a unit. So now the clicker's working. Okay, so basically it depends on how we look at it. The area of the rectangle is going to be 1 times x, or just x, or it could be xy, depending on how you're defining it. And the little squares are 1 or y squared. So it just depends on how you want to define which. And obviously you have to make that pretty clear in the beginning. Okay, so there we are. So what can they help us with? Well, they can help us with addition, because we're looking at like terms. And so, or like things, I guess it would be better, like shapes.
Oh, because someone just flipped over.
Okay. We can subtract. Okay, we can multiply polynomials by polynomials with positive terms. And we can factor them. Okay. So initially you would start off with just the positive ones. So we're looking at the, obviously these look a little bit more like rectangles.
They do.
I think because it's a wider screen.
Oh, okay.
It's not giving
That
us-
could potentially, they'll throw a kid.
Yeah.
If they even
Could.
got what it's supposed to mean.
Well, and I don't know on the smartboard if you can,
Because
make it
over on
more
the screen, they're perfect.
Yeah, make them more square, yeah. Well,
Yeah.
I don't know, but anyway, so it's supposed to represent 4x squared, and they're dealing with the manipulatives, which are squares. And then these would be x's, and then we have units. So we have 4x squared, 3x, and 6 units. So let's say we want to subtract. Okay, well, what are we going to do? We're going to subtract this amount. So we're going to take our original amount, and we're going to cross off 2 of the squares, and then we're going to cross off 2 of the x's, and then we're going to cross off 4 of the squares. And so what are we left with? We're left with that. Or we can say take away.
2x squared.
Right?
But I gotta ask you about that middle, that equal sign. That's making me nervous.
Okay.
But I wonder if we could, would arrows be appropriate
That's
instead
what I
of
do.
putting equals?
Yeah.
Mhm.
Probably
Okay,
it
that
would be.
Goes to that.
Well,
Okay.
well, I don't know.
Or I don't know,
Think
is that
about-
not acceptable?
Well,
Like,
it's
Well, no,
equal,
it
it's
is
equal to
just
the
It
sense
is
that
equal
if
to-
you
yeah.
multiply the negative by that second pair of blocks,
Right.
the x dot is supposed to be flipped or read.
We can talk about it, turning it over,
So it would be.
depending
it
on
would
what
be
kind of
equal.
tiles you have, because I think, see, Mary, do you have the one with the ones on the opposite side? Are they different
Right,
colors?
right.
Yeah.
Right.
So in other
Oh,
words, we could, for the
Positive
subtraction,
yellow and-
you could
So
turn
it's
these
the-
over and that would be
it's up to
gold.
the idea of multiplying
No,
by
well,
negative.
some of the, I thought I had some, but yeah, these,
See, I've seen the plus and the minus.
yeah,
Well,
plus
this-
and minus. So
these
yeah,
are
the
two
black
different
must be the minus sign, minus side. Okay, but, yeah, I guess So we're gonna say we're just subtracting, like, the two expressions, rather
Yeah.
than say that they're equal to something. Okay?
Yeah, that's just part of your process, I guess.
Yeah, I guess it is.
I mean,
Yeah,
I
I
see where
guess
you
I,
cross
you know, I mean,
off.
I'm really good about, you know, like working an expression down. But you're right, it's not equal to something at this point, so we're just simplifying it, so, yeah. Okay, so now we're not working, oh, we are working.
Oh, dealing with negatives.
Dealing with negatives, so, what must we do here? Well, we're taking 2x squared away from an x squared. And obviously we can't do that, right? So what we need to do is we're going to add, we'll go back.
Try hitting that left
Oh,
arrow.
on the left arrow, there you go. What it is I don't teach in a classroom that has this. We have a couple.
And I haven't taught in a classroom that has this in a couple of years.
Just hit the board again.
Like
There
you
you
said.
go.
Thank you.
It's fine.
Yes. Okay, so what we're going to do is we're going to add a positive x squared and a negative x squared, and 2 positive units and 2 negative units. And we add them to the left. So then what that allows us to do is subtract off 2 positive x squared. So we have a positive x squared and a positive x squared, so we can cross off those 2. Is that okay? Mary,
Yeah.
is that all right? I guess I could mark them on here too, if I wanna think about it that way. I'm gonna cross off this one, and I'm crossing off this one. So this leaves me with the 1x squared, and then I need to take, I just need to take 1 off of here, so that's good. And I need to take 3, so I have to take 1, 2, 3 off. So what I'm left with then is I have a negative x squared, 2 positive x's, and 2 negative 1s.
Now, just, do you guys use these for, I don't see that I would use it for adding and subtracting polynomials, because if they knew integers, is this such a big leap? Do you use this for adding and subtracting?
I haven't, but I was gonna write it down as possible for
Okay.
my, low
I
level
do it
class.
different.
I've done the multiplying though, and
Right,
completing
the
the square.
multiplying, yeah.
Completing the square, it was nice for,
I
what
do it
would I-
different. When I subtract, I do it differently.
Okay,
How
what do
would
you do, Joe?
Oh, I'd love to.
I'm trying to set the problem up on my box. Can you go to the next one? Oh,
You
not
wanna do the
next one.
multiplying?
No, the
he-
other one.
He wants to do this
That-
in
oh,
previous
that.
one.
I didn't just realize that you know what, I've got a pen in my hand.
So go back one more. There you go.
Okay.
So the way I learned algebra blocks and how to use them is as a negative, you flip the blocks. That's what you're talking
That's-
about.
okay,
So
that's
I have
another
Okay,
my-
so you
Yeah.
have
Yeah.
negative
I have-
2x
I
squared.
have, what I have here is my negative blocks, which are red. I don't know if you can see it.
Okay.
Can you guys see
No,
it
I got
there?
the right idea. Okay.
Can you see what I have here?
Yeah.
So I have what she has there, except the minus one, which
Mhm.
should be 2 more red ones. All the ones that are subtracted are red.
Okay.
So the positive is gonna be the different colors. And the ones that I have anyway, when you, as soon as it's negative, you flip it over and the other side is red. And so you just you match up the ones that, you pair them. Because one, the blue one, or the one that's colored, it
Right.
cancels out by the minus one.
Right,
So you
so
match
you
them.
just match and
Right,
toss.
so I match
Okay.
this with this one, and I take that away.
Right.
I match this with
The 2 x's.
the 2
Yeah,
x's,
The
and I take
positive
that
x
away.
and the negative x.
And I take a negative one and
And
take those away.
okay.
And what do I have left? I have negative x squared.
Right. The
Plus 2x.
Positive 2 x's and then the
minus
negative
2.
2?
Right.
Okay.
Beautiful.
Okay.
Okay.
That I see, I have seen people do this, the adding, so that they can balance. I actually like this one a little better
Yeah.
with the colors.
Well, that's it, you know, and some children will like it one way
Right,
and some will
whichever.
like it the
And
other
both
way.
approaches are mathematically sound.
Sound,
Yes.
Right.
So you do what
Yeah.
works for the.
And
Right.
I guess, you know, when Jenny was talking earlier about showing multiple representations, and it does.
This definitely.
Makes you more conceptually aware of what's happening here. I students ask you that. I know one way, why do I need to know the others? And sometimes I feel that, I never felt that way until we got to the computer and copy paste. How many different ways can we copy
Yeah,
paste?
good point.
And, but I only need to know one way, as long as it works for me every time. But occasionally I'll run into something like in our Blackboard. I can't just copy paste on using the mouse. I have to do the Control V, Control P. So I do need to know another way, but it happens. Okay, so
Let me
here
set
we are
this up.
trying to multiply.
X plus 2.
We won't forget it.
Okay, so,
One more.
one more?
Yeah, we wanna go to multiply, right?
Yeah.
Yeah,
X plus 2
right.
times
I was
3x
just trying to-
Do you want me to try, can we move, you want that out of the way?
I just thought it
Like
was
further back
easier
down?
for you
Okay.
to see things, and I know that I've moved this before, but
Just
I,
hold your finger on the top and just drag it down.
Pull it down.
well,
There you
okay.
go.
And I have moved it
Yes.
before, it's just, it's like this thing, it works some of the time and not the other time. Okay, so the x plus 2,
Mary, will you explain
oh,
Oh,
this? Look at this, she's got it here.
you got it
well,
done?
that's because I'm practicing.
Mhm.
So x plus 2 is being multiplied by 3x plus 3. And we're gonna set x plus 2 up vertically, 3x plus 3 horizontally. When I multiply the x times the first x, so the x on the left times the one on top, you end up with x squared. Now you have to take that x on the left and multiply it by the second x to get another x squared, and then x one more time by the last x to get another x squared. Now, don't forget x times 1,
Right.
and that would be the one there, and then x times 1 again, and one more time. And then you have to repeat the pattern with your ones. 1 times x, now I'm out of these guys.
So then
Oh,
you're right,
yeah.
so it's just,
Right.
we're repeating that time
Right.
pattern? And we're
Yes.
going to repeat it a
And
second
then they
time.
see how it's distributive and stuff. And so that would, for those who are so worried about foiling, you see the distribution.
Boy, you see the distribution, don't you?
Right.
Yeah.
Rather than foiling?
Yes.
I was at a presentation by one of our senior math students, not math ed, fortunately, who was talking about infinitely foiling. I thought I would scream if he said it one more time, we're infinitely foiling. Oh, give me a break. Okay, so area of the rectangle.
That's great.
Infinitely foiling.
That's the title of our book, Mary, Infinitely
There.
Foiling.
Foiling, yes.
Infinitely foiled.
Yeah, right.
Infinitely foiled,
By
beautiful.
CCSSM. Okay, so what do we, and that's it, then we just see what we've got. So we have the 3x squared, we have, 9, so we've got these x's, and we don't wanna forget about those, and then we have the 6 units.
Yay.
Okay.
I'm trying to think how we could relate this to
Yeah.
what Jenny was teaching today. I mean, could it, the problem
She
solving?
touched on it, the idea of factors and the product being,
Well, rectangularly, you know how you set
Yeah.
up your 1 times the other on,
Right.
like if you were to show 3 times 4 on graph paper.
Right.
So that could at least explain why we're setting this piece up.
it is
and how
absolutely
it's all-
consistent, isn't
What's the
it?
modality? We're looking at a
Right.
diagram modality.
I mean, that would be one way, because I'm gonna have to explain every last piece of this. So, and
'Cause
they're
I
gonna
think-
ask, well, why are you doing it this way and that way?
I think you
I
could
think
do
it
almost
would-
all algebra related to what she's saying here. You could relate, I must.
Right.
A lot of it you can.
I can't think of anything.
And the other thing that just knocks my socks off, a kid learns to multiply in about 3rd grade, or,
Right.
3rd and 4th grade, and if they're using an area model,
This should
this is
go
it.
right
That-
into it.
That is an
Right.
underlying concept that goes all the way
Right.
through, all the way.
It's the great connection back to what we did
Yeah.
originally.
In a way, it's kind of like multiplication table.
It is, yes, I thought of that too. Kids
Where it comes
create those
from.
tables, it's the
Yeah.
same thing. And what do they do in science when they try to get all
The
kinds?
Unit squares.
Yeah. I'm
Oh,
sorry.
those gene things?
Yeah,
Yes.
those gene things.
They did that before, they did factoring for me. which we use a little square thing. Hey, that's a Punnett square. What?
Yes.
It's a Punnett square. Oh.
Somebody's gonna have to show me that, 'cause I would like to know what that is.
I wanna see
Oh,
the
it's
going
square?
backwards
I don't know
now.
what that is.
Oh,
I mean,
the
I thought we-
factoring,
Factor.
yeah.
Yeah.
So what
Okay,
you wanna
so
do is you have the 2x squared plus 7x plus 6.
Okay, hold on, 2x squared. Now, are you gonna show them where to put the pieces?
No, I'm going to ask
Okay,
them to
so
make
let
a
me see what I can
rectangle out of
do.
it.
Okay. 2x
It's just
squared
the person who came up
plus,
with the idea.
Yeah.
let's see what I can do.
So sometimes it takes some work to figure those
Right,
pieces
right.
into a rectangular shape.
Because that was it, last night I was working on the
Yeah.
virtual manipulatives,
So like this is a
Yeah.
way of figuring it out.
and I was having trouble with what were they talking about here? How are they coming up with this?
You got it, you got it. Oh, I
Wait,
love
no,
it.
but it's plus 6 and I only have 3.
Factory?
I'm trying to get the,
You've
like
got
if someone
2x
asked
squared.
me to do 2x squared plus 7x plus 6 and to create it so that I can break it apart to factor it,
Oh,
There's many ways you can do it.
Yeah.
well, start showing me.
well, it's
Well,
not
actually, not many.
six.
There's only one way. There's only one
Okay,
way.
show, because I'm gonna have.
There's only one way that
What was
works.
it again?
You need the
But
6,
we're starting
you don't
with
have
that
6
one.
Let her
times,
do
6
it,
little
she's
ones.
doing it.
Well, I was
2x
playing
squared
with
plus-
it. So I have my 2x squared, here's my 7x's, and here's my 6, and I'm
Right,
supposed
so
to
you're
make a
supposed to make a
rectangle.
rectangle, yeah.
Right.
There's only one way to do it.
She's working on that.
Right,
Well,
so
you
what I
can
would
tell
do-
me.
It's challenging.
I don't wanna
A
get-
perse-
It is.
Persevere.
It is,
Persevere.
so.
It's a
sorry.
puzzle.
Persevere, who wants to persevere when I
So
can have
would do
someone?
this- I would work with these first.
Okay, the little guys?
Oh,
So,
really?
see, there's that, right? And then you
Okay.
can have, well, there it is, right there. Because once you get
Oh,
that.
what a show
Oh, I
off.
love it, what a show off.
No, I've just done it before.
But this, yeah, because
So
you
I
know
wouldn't,
your
I wouldn't
things are
work, I wouldn't work with
ones.
these two
Okay.
first, because the
Ones.
easier, because this is the
This is
one,
gonna be
this
the
is the one
crux.
It
that.
has to fit.
Right, that
in
has to
corner.
fix. And
Okay.
so you would
Piece
fit.
the square.
So
you-
start, so it's almost
Well,
in reverse.
I would do this, start there.
Okay.
Because you're always gonna have these off to the side. No
Okay.
matter what you do, you're always gonna have these off to the side. So I would make one square with the large X, and another rectangle, I guess, not
Okay.
square, a rectangle with the smaller ones. So you could
I
do
should have
that.
typed out wrong.
Oh, and then the 2 and the 3, okay.
But then
Oh,
you
well, I'm
see-
slightly
and then,
raised.
and then, well, if you,
Well,
well,
but
that
then it
doesn't
doesn't
work, well, then,
balance.
okay, then just move it over
Ah,
here, and then
okay.
then you're just manipulating and trying. So I can do that. Oopsies.
Got it, and then he
Voila,
comes this
ta-da,
way.
Yeah.
So these trinomials that we factor can only be factored one way. Hence, so there's only one arrangement of these tiles, am I right?
Yes.
Of course, when kids are factoring numbers, sometimes they can be factored in more than one way.
Right.
And so, but we could show that with these. They would just use the units in elementary school, wouldn't they, to,
But it's still,
I
it's
love
a
it.
rectangular array, just like we talked about with area, the
Exactly,
area model. So
exactly.
it's, again, we're still doing that.
damn, I wanna go back to teach elementary.
I'm telling you, I'm thinking
See,
4th
it's all-
grade
we
looks
should-
really
we
cute.
should, like flip. High school teachers should go down
I
and
would
do the.
like-
I think
the
everybody should
elementary
have the
and then
chance
to
elementary
do
all
that.
Yeah.
Cycle
It's
it.
like, what do I have to do? How do I conjugate a verb?
Okay, we'll just do subject specific
Yeah.
sections, okay? How about that one? And then we
Okay.
can do those fun things, like really
Okay,
keep on
so
that.
then from here, you would just, okay, so first I set it up, and now I have to figure out what my 2 binomials are. So obviously, that's an X,
I like
this
to
is
go
2
like
X's. Okay, I get it.
Yeah.
I get it.
Done.
Okay, so the key is this.
Yeah.
I'm gonna have to practice those, thank you. Thank you.
Jasmine, do
So
you get
almost
it?
backwards.
I do.
Look at
Isn't that
this.
kinda neat?
It's interesting because I'm just used to doing the box method and going from
Yeah,
there.
just do the math.
Find
Yeah.
2 numbers that add to this and multiply
Yeah.
to that, you know?
What's kind of, because if you think about what's kind of, may I?
Oh, sure.
What's kind of cool with that is you can go back to the box method, and you can have your, because you literally have 2 boxes. You have your 2 big boxes over here, right? And I forgot how many. There's 3 boxes over here, right? And there was like 2 over here, right? And then we had 1, 2, 6 small ones over here,
Right.
right? But then if you go back to this box method right here and then do a representation by numbers, as in which is in that, you got 2x squared. 1, 2, 3, 4. 3, sorry. I guess screwed that up. We got 3x here, we got 2x here, we have 6. Well, that's just,
Right,
and then that's what you have off to your side.
right.
That would be